repeated measures analysis of variance in SPSS. You'll want to do this when one of your independent variables is time. In other words, you're taking repeated measurements of your dependent variable, again measured on a continuous scale. And we want to see how one group changes compared to another. So this is similar to a two-way ANOVA, but in this case, one of the variables is time, and so we need to treat that as a within subjects variable. Now we can do this using ANOVA, or we can of course use regression since they're the same thing. In this video we will run through the ANOVA. So we're now on this video over here. Again, we have an SPSS checklist, and we'll be using our practice data sets over here. So if we click on that, we're going to go to the pre-post data set. And this will give us a data set from 30 subjects in two different groups, control and intervention. And we have baseline scores and follow-up scores. So we need to get this into SPSS, highlight our data, head on over, and paste. Now we just need to give some names. This first one is just the subject ID, which we don't actually care about. We got our group, and we've got pre and post. Baseline, follow-up, name them whatever you want. It doesn't matter. I'm going to say that the ID is really just a label. It actually means nothing. It's not even ordinal. It's really just a number that means nothing. 2 is not more than 1. These are just IDs. But the pre and post scores are indeed scale. Those are numbers and they do have value. Now, you might think that you'd have a variable saying whether these are baseline or follow-up, but no. In order to run repeated measures analysis of variance in SPSS, we have to use this format where we have a column for each of our time points. So if I had 3 time points, 3 different measurements repeated for each subject, I would have a third column over here. I don't have that, so I only have the 2 columns. But ensure that you have this data format. All right. I know we don't have any missing values. I'm not going to explore any box plots or anything, but that's a good habit to get into. Instead, I'm just going to jump right into the repeated measures analysis of variance. So we go to General Linear Model, and now repeated measures is what we select. So we want to set up a factor here. This already exists because I've done it, but let's get rid of it. And I want to make a factor called time. You can call this whatever you want. It really doesn't matter. But what does matter is that you give the correct number of levels. I have a pre and post. So there are 2 levels to this variable of time. So I'll add it, and we're good to go. Now I need to tell it that within subject's variable of time, what are my 2 measurements that I have? Well, I have pre, and that goes first, and I have post, and that one goes second. My between subjects factor is going to be which group they were in, control or intervention. Very good to make sure you get your within and between groups factors straight here. Now I need to just specify what sort of output I want here. And I want to get that interaction plot, which for some reason is already there. So I'm going to add time on my horizontal axis. So I'll have pre on the left, post on the right. And I want a separate line for each group. I'll add that. That'll give me my interaction plot. And I have my error bars selected already, but please make sure you do this. Must have our error bars selected. So I'll click continue. From here, we don't have to specify any post hoc tests because we only have 2 levels for each of our variables. We have pre and post for time, and we have control and intervention for group. No need to specify anything here. For EM means, we do want this, and these are already over here for me. Lucky me. If they weren't, I would just simply highlight them over here, and I would like group time and the group by time interaction. We'll compare the main effects. We don't need to do this, but we will get in the good habit of adjusting for multiple comparisons. Again, there are 2 levels, so it won't matter, but we're going to do that. We'll click OK. And here I need to save the unstandardized residuals. That's going to let me look at homoscedasticity and the normality of residuals. Okay, now we have some options here. What do we want? Well, we want descriptive statistics, absolutely. The estimates of effect size are just there for other folks. They don't mean much to me. And we'll do our homogeneity tests. These are nice. So we'll continue, we'll click OK, and if all goes well, SPSS spits out something that looks like this for you. Okay, so we got to check our assumptions. Now, we assume independence of observations, and that has to do with study design. I happen to know that these are indeed independent observations, right? In other words, when I took the baseline and follow-up values from this subject, it had nothing to do with the baseline and follow-up values for this subject, or any of these down here. And that's what it means to have independent observations. There's really no statistic here that's going to tell us that. That's just pure experimental design. Now what we need to think about is homogeneity of covariance. So we have between subjects factor, right? What we're going to do is make sure that we have equal covariance here, and that's this boxes M test over here. We want a non-significant effect, and indeed that's what we're seeing. Notice the p-value here, much larger than 0.05. Okay, we're not concerned about any differences in covariability. The most critical assumption of repeated measures ANOVA would be sphericity. Hey, luckily we don't have to worry about that. We only have 2 levels. You try to run a sphericity test on that, we have 0 degrees of freedom. So there's nothing to do here. We don't have to worry about it. And as you'll notice here, there's all these adjustments that are made in case sphericity is violated, and they make absolutely no effect on our main effect of time or our group by time interaction. Because again, we have to have sphericity. This just says that the differences between all the possible pairs of those within subjects variables have equal differences. We only have 1 pair, so there's no degrees of freedom here. Nothing to worry about, thank goodness. But if we did have multiple levels of our within subjects independent variable, if we had more than 2 levels, then we would have to worry about this. Luckily, we don't. And what we'd want here is a non-significant effect. Okay, how about the normality of those residuals? Okay, well, we have to do ourselves a little extra step, so we'll go back over here. And what we want to do is go to Analyze, Descriptive Statistics, and Explore. We've done this many times at this point. Here what we want to do is add our residual for the post. That's the one that we care about. We'll put our group on there, and statistics, plots. We want to make sure we don't have stem and leaf. It's pretty pointless. Histogram with some normality plots. Cool, excellent, click OK. It's going to jump us down to the end, and what we want to make sure here is we don't really have any major violations of normality. I know this doesn't look pretty. We're okay. Right, nothing to see here. No significance on our Shapiro-Wilk. So it's all good. We can look at our QQ plots. Yeah, these dots follow the line pretty well. I'm not too concerned, right? And I'm really not using this analysis to make any predictions. I'm just here to describe between group effects. I would worry a whole lot more about this if I was using regression to try to predict a thing. I'm not. So I feel pretty good on all of my assumptions. Let's go back to our output and see what we have. So I'll just click over here. Again, we don't care about this stuff. Okay, test of within subjects effects. So time, we have a main effect of time. Let's just head down here. This table is much easier to look at. Okay, time, indeed there's a main effect, so something's going on. We are changing over time. Do we have a group by time interaction? Yes, absolutely we do. Now let's have a look at what that looks like. So we scroll on down here. I want to see what that interaction looks like because in the last video we didn't see an interaction. Notice the slopes here are different. right? When we go from baseline, where we look about the same, to follow-up, where maybe we're looking different, right? My 95% confidence intervals aren't including the average of the other. Look at the slope on this red line. So the intervention group is improving a whole lot more from baseline to follow-up than the control group. They both increase, but one increases a whole heck of a lot more. All right, now I'm going to scroll back up and we're going to take a look at the output. So the estimated marginal means is what we're after here. So first it talks about group. Is there a difference between the groups? No. Right, the marginal mean for the control group is about 74. It's about 75 for intervention. I am rounding. But if we look at that difference of about 1.4 points, no, it's not significant. My p-value is greater than 0.05, and my confidence interval includes 0. Now, could there be a meaningful difference? Yeah, perhaps. Right, if we call a 5 percentage point difference meaningful, okay, so maybe we could use a few more subjects than 15. Sure, maybe we're a little worried about power here. Let's have a look at time. Did things change between baseline and follow-up? Absolutely, right? So we can most certainly detect that effect of time. Look at this, confidence intervals anywhere between 11.5 and about 7 points. We have a whopping effect of time. Now we noted above that we had a significant group by time interaction, and we saw the plot earlier. Hey, one group got mo better than the other. Here's what we're not getting, though, with this analysis. How much better did the intervention group improve than the control group? And this just simply doesn't tell me. I don't get to see any difference between this improvement and this improvement. To do that, I have to run another analysis. And for that, we are going to turn to regression, which is the same thing as an analysis of variance, but it gives slightly different output. Okay, so what would we want to report here if we're running this repeated measures analysis of variance? We're going to head back up here, right, to our tests of within subjects effects. We'd say that we have a main effect of time. We can report the F statistic, p-value, right, degrees of freedom, of course. Partial eta squared is something that people want. Never made a lick of sense to me, but hey, it's there. Mainly what we want to do is head on down to our estimated marginal means and make sure we're reporting these confidence intervals. That'll let us know that maybe we're slightly underpowered here, since we're saying that both 0 and a greater than 5-point difference could be there between our groups. We're probably not as worried about our power, though, if we're just thinking about the effect of time. But really the whole point that we're running this analysis is to say, did one group improve more than another? And this just simply doesn't give me this. So in order to get that important confidence interval, we're going to have to turn to multiple linear regression, and we'll cover that in another video. If anything is unclear here, please make sure you use the questions box. Happy analysis.